The Sun, our closest star, has always been a fascinating and powerful force in the universe. Its energy fuels life on Earth, but it can also unleash intense solar storms that can affect our planet in profound ways. In recent years, there has been a growing interest in understanding the Sun's behavior, particularly its sunspots and solar flares, due to the increasing vulnerability of our technological infrastructure. These phenomena, while beautiful in their auroras and lighting displays, also have the potential to cause significant disruptions on Earth. This article delves into the real-world implications of recent solar activity, focusing on sunspots AR3664 and AR3697, their potential impact, and what this means for our future. What seems like a fascinating light show is actually a warning sign of how connected we are to the Sun's cycles and how prepared, or unprepared, we are to face their consequences. Throughout history, solar activity has been a subject of both wonder and worry. The Sun, a massive ball of hot plasma, is not just a source of light and heat, but also a dynamic, volatile object with a complex magnetic field. This magnetic activity creates sunspots, areas where the magnetic field is particularly intense and causes disturbances on the Sun's surface. These disturbances can sometimes erupt into solar flares or coronal mass ejections, CMEs, which are massive bursts of solar wind and magnetic fields that are sent out into space, sometimes towards Earth. These solar storms can have a range of effects, from beautiful auroras to widespread disruptions in communication, power systems, and even our navigation satellites. The intensity of these storms has been increasing recently, and scientists are particularly concerned about sunspots like AR3664 and AR3697. These sunspots have already caused significant solar flares, and there is worry that they will continue to intensify as we approach the peak of solar cycle 25. Which is expected to occur in 2025. One of the most remarkable solar events of recent years occurred in May 2024 when the sunspot AR3664 released a powerful solar flare. The flare, which was observed by NASA's solar observation satellites, sent a massive stream of charged particles toward Earth. These particles, traveling at incredibly high speeds, interacted with Earth's magnetic field, causing a geomagnetic storm. The effects of the storm were felt all over the world, but one of the most striking consequences was the auroras that lit up the night skies. These auroras, typically seen only in polar regions, were visible as far south as the United States, the UK, and parts of Europe. The colors were extraordinary, ranging from deep red hues to vibrant green and blue. While these displays were beautiful, they were the result of a solar storm that had the potential to cause much more harm. Solar storms, like the one triggered by AR3664, release large amounts of energy into space. This energy can affect various technologies on Earth, especially those relying on satellites or electromagnetic systems. Power grids are particularly vulnerable, as the charged particles can induce currents that can damage transformers and other electrical components. During the solar storm in May 2024, there were reports of power outages in some areas, as well as disruptions in satellite communications. The event served as a reminder of just how vulnerable we are to the Sun's unpredictable behavior. While the storms that occurred in May were intense, they were not as devastating as they could have been. The Earth's magnetic field acted as a shield, protecting us from the worst of the storm. However, scientists warn that future solar storms, particularly those associated with sunspots like AR3664 and AR3697, could be much more dangerous. What makes sunspots like AR3664 so concerning is their size and magnetic activity. These sunspots are much larger than the Earth, and they can hold massive amounts of energy that can be released in the form of solar flares or CMEs. The magnetic fields in these sunspots are highly unstable, and when they snap or reconnect, they release enormous bursts of energy. The flares that result from this process send streams of charged particles toward Earth, and when these particles collide with our atmosphere, they can create auroras. These auroras are a beautiful visual manifestation of the Sun's power, but they also signal the arrival of a geomagnetic storm. These storms can interfere with communication systems, disrupt satellite operations, and cause power outages. The storms can also affect navigation systems, as the charged particles interfere with GPS signals, making it difficult for people to rely on these technologies during a solar storm. In addition to the immediate effects of solar storms, there are long-term concerns that scientists are monitoring closely. The most serious risk posed by solar storms is their potential to damage Earth's magnetic field. The magnetic field acts as a protective shield, deflecting harmful solar radiation and protecting life on Earth. However, the Sun's increased activity in recent years has put more strain on this magnetic field. During the solar storms in May 2024, scientists observed that the magnetic field was being stretched to its limits. There were signs of regional weaknesses and even holes in the field. While these disturbances did not cause permanent damage, they raised alarms about the future. If the Earth's magnetic field were to fail, even temporarily, we could be exposed to higher levels of radiation from the Sun, which could have severe consequences for life on Earth. Prolonged exposure to this radiation could even lead to the loss of Earth's atmosphere, much like what happened on Mars billions of years ago. As we move further into the peak of solar cycle 25, the potential for more intense solar storms is high. The Sun goes through an 11-year cycle of activity, with solar flares and sunspots being most common at the peak of the cycle. We are currently in the early stages of this peak, with the most intense solar activity expected in 2025. The sunspots AR3664 and AR3697 are just the beginning of what could be an even more powerful wave of solar storms. As these sunspots continue to evolve, scientists are keeping a close eye on their behavior, as even smaller sunspots can release significant flares that could disrupt life on Earth. The activity of these sunspots is a reminder of just how vulnerable our modern world is to the whims of the Sun. Despite the growing threat posed by solar storms, there is a silver lining. Scientists and space agencies are actively working to better understand the Sun's behavior and improve our ability to predict and mitigate the effects of solar storms. Observatories like NASA's Solar and Heliospheric Observatory, SOHO, and other space-based instruments provide real-time data on solar activity, allowing scientists to track the movement of sunspots and predict solar flares. In addition, technological advancements in space weather forecasting and communication systems have improved our ability to prepare for solar storms. Early warning systems have been developed to alert satellite operators, power grid managers, and other stakeholders about the likelihood of a solar storm. These systems can help mitigate the impact of solar flares by allowing for the temporary shutdown of vulnerable systems or the implementation of other protective measures. Despite these advancements, the threat of solar storms is still very real. Even with early warning systems in place, the effects of a powerful solar flare or CME can be devastating. The disruptions to satellite communications, power grids, and navigation systems could lead to widespread chaos, affecting everything from air travel to military operations. The potential for long-term damage to Earth's magnetic field is another concern that scientists are closely monitoring. If the Sun continues to grow more active in the coming years, we may be forced to reconsider how we protect our technology and infrastructure from the effects of solar storms. It's a sobering thought, but one that underscores the importance of continuing to study the Sun and develop strategies for dealing with its unpredictable nature. The events of May 2024, while fascinating, serve as a warning. The solar flares and geomagnetic storms that occurred during this time are just a taste of what could happen as the Sun's activity increases over the next few years. As we approach the peak of solar cycle 25, the intensity of solar storms is expected to grow, with the potential for more powerful sunspots like AR3664 and AR3697 to cause widespread disruptions. While the auroras that accompany these storms are beautiful, they are a reminder that the Sun is a force that should not be underestimated. As we continue to rely on technology for communication, navigation, and power, we must be prepared for the possibility of solar storms that could disrupt life as we know it. The next few years will be crucial in determining how we respond to the growing threat of solar storms. Scientists will continue to monitor the Sun's activity, and space agencies will work to improve our ability to predict and mitigate the effects of solar flares and CMEs. However, the true test will come when a massive solar storm hits Earth, and we must rely on our preparedness and resilience to navigate the challenges it brings. The beauty of the auroras may continue to captivate us, but the reality of the power behind these events is something we must take seriously. The sun may seem far away, but its influence is closer than we think. It is up to us to ensure that we are ready to face the storms that lie ahead.